What if I told you that every single file you download, every show you stream, is fundamentally broken, riddled with errors, yet somehow it arrives perfectly? This isn't magic. It's the work of invisible guardians called error-correcting codes, the unsung heroes of our digital world. To understand the solution, first we must understand the enemy: noise. In the digital world, noise is any interference that corrupts data. This happens everywhere: a satellite signal weakened by a storm, a tiny scratch on a Blu-ray disc, or even just interference with your home Wi-Fi. Without correction, this noise results in chaos: pixelated images, glitchy video, and corrupted files that refuse to open. The core idea behind fixing this is brilliantly simple: redundancy. We intentionally add extra data to the original message. Think of it like shouting a message across a noisy room. You might repeat the keyword 3 times to make sure it's understood, even if one version gets garbled. Our first guardian is CRC, or Cyclic Redundancy Check. It's like a super fast detective, excellent for detecting if an error has occurred. It works like this: it performs a special math calculation on the data and produces a short checksum. If the data changes, the checksum will no longer match. Technically, it's a polynomial division where the remainder is the CRC value, but all you need to know is that it's an incredibly quick integrity check. You'll find CRC protecting data transfers in Ethernet, Wi-Fi, and hard drives, ensuring that what's received is what was sent. But what about fixing errors? For that, we need a stronger code, like Reed Solomon. It's a master at correcting burst errors, where a whole chunk of data is lost at once. Think of it like a Sudoku puzzle. The rules are so rigid that even if several numbers are missing, you can use the surrounding information to deduce the correct values. Reed Solomon treats blocks of data as points on a graph. It calculates a curve that passes through them. Even if some points are knocked out of place, it can regenerate the original curve and fix them. This power makes it perfect for physical media, where a single scratch or smudge can create a classic burst error, wiping out thousands of consecutive bits. That's why Reed Solomon was the king of CDs, DVDs, and Blu-rays for decades. You'll even find it in the QR codes you scan every day. Now meet the modern champion, LDPC, or Low Density Parity-Check code. This is the powerhouse that gets us incredibly close to the theoretical maximum speed of data transmission. Imagine a massive, complex web. Each bit of your data is a node, and it's connected to multiple check nodes that monitor it and its neighbors. When a bit is flipped by noise, the check nodes it's connected to raise an alarm. Through an iterative process, they essentially vote on the bit's correct value until it's fixed. This iterative approach makes LDPC extremely powerful and efficient, especially for channels with lots of random noise, not just big bursts. It's no surprise that LDPC is at the heart of the most demanding modern technologies: 5G, Wi-Fi 6, high-speed SSDs, and deep space communication. So let's recap. CRC is the fast detective, a simple checksum perfect for quickly detecting if something has gone wrong. Reed Solomon is the specialist, a robust code that can reconstruct entire chunks of missing data, making it ideal for physical media prone to burst errors. And LDPC is the modern champion, an incredibly efficient code that uses a web of checks to fight random noise, pushing the limits of data transmission. But they aren't competitors. They work as a team. A system might use a quick CRC check first, and if that fails, it calls in the heavy hitter like LDPC to perform the correction. From the photos on your smartphone to the signals sent back from the Mars rover, these codes are the reason our digital communication works so flawlessly. Every piece of data you trust, every byte you consume, has likely been shattered by noise and perfectly reconstructed by these incredible mathematical tools. So next time your 4K movie streams without a single stutter, take a moment to thank the silent guardians of your data. If you found this fascinating, subscribe for more deep dives into the invisible technology that shapes our world. Thanks for watching.